Alright, so we're going to start the review at 10.1. Tell whether segment AB is tangent to circle C. So in order for it to be tangent, the line and the radius must be perpendicular. So that means the line in question and the radius, which here would be a diameter, must be perpendicular. So they must intersect and form 90 degrees. So we need to check to see if this forms a right triangle. So a lot of people knew to use the Pythagorean theorem, and they knew that the hypotenuse would be 60. But here's the common mistake. They used 48, which was good, but then they tried to use 20, but you can't use 20. 20 is only this piece of the side. So if you notice, it goes from the center to the edge, so we call that the radius. The radius of the circle is the same all the way around. So if from C to D is 20, that means from C to A is also 20, which means the full side length is 40. So we are going to square these. 48 squared is 2304. 40 squared is 1600. And 60 squared is 3600. We're going to add the left together and see if it equals 3600. Add them together and they definitely do not. So this is not tangent. And then the reason would be the radius and the line are not perpendicular. Alright, then we're going to do the next section. It says find the measure. We're also going to tell whether it is major, whether it's major, minor, or a semicircle. Remember that a semicircle is equal to 180 degrees. A major arc is greater than 180 degrees, and a minor is less than 180 degrees. So we'll start with the first, which is JL. Because it is two letters, it's obviously going to be minor, which means my answer should be less than 180. So starting at a J, I need to go directly to L, the shortest route, which would be this direction. So then we're going to add 53 and 79, which makes 132 degrees. I'll just put it off to the side. Alright, the next one, KM. KM. So since it's two letters, again, it's going to be minor. And then I want to go directly from K, use the shortest route to get to M. So I'm going to add 79 and 68 together, which is 148 degrees. Alright, the next one, arc JLM. So starting at J, go in the direction of L, and then end at M. So we're going to need to add 53, 79, and 68 together, which is 200 degrees, which makes this a major arc. Alright, and the last is JM. Again, it's two letters, so it's going to be minor. You're going to start at J and go directly towards M. If you notice, there's no central angle. So what you need to know is that all the way around the circle is 360 degrees. We already said that this portion of the circle was 200 degrees, so we can subtract from the 360 to figure out that this piece, this missing piece, would be 160. which again, since it is less than 180, that is minor. This next problem says find the value of x, then find the measure of the red arc. So if we notice, we are given from A to B, we're given a value for them. A and B sit on the diameter, so that means that what I've highlighted in green is equal to 180 degrees. So what we're going to do is we're going to take both pieces, so take x, and we're going to combine it and add it with the red arc, which is 2x minus 30, and then we know that they will add up to 180 because they form a semicircle. So we're going to combine like terms. X and 2x make 3x, drop down the minus 30, add 30, you get 210, so 3x equals 210, divide by 3, and x equals, x equals 70. So that's the first part. It says find the value of x, and then it says find the measure of the red arc. So the red arc, if I erase this, is BC. So we're going to find the measure of BC, which is 2 times x minus 30. So we're going to do 2 times 70, which is 140, minus 30, which makes 110 degrees. An easy way to check yourself, if this arc is 110, okay, 1 second, and this arc is 70, add them together and they make 180. Next says find the measure of the red arc or chord in circle dot C. Whenever you see this circle dot, it's saying circle C. I know it looks weird. So we're trying to find the whole red arc, but something that we need to know first is this arc. This arc corresponds with this angle. And if we were in class, I'm sure you guys would knock this out of the park. What relationship do these two angles have? Dun, dun, dun. They are vertical, which means that they are congruent. So if this arc is 110, this angle is 110, which means this angle is 110, which means this arc is 110. So that doesn't necessarily answer the question. I want to know the red arc completely, so I would have to add the 110 and the 60, which makes 170 degrees. So in 10.3 we learned about chords, and basically it said if you have congruent circles, or the same circle, and you have congruent chords inside of those congruent circles or the same circle, then it cuts two arcs and makes congruent arcs. So if they're congruent, we know that 6x minus 28 will equal 4x plus 20. Move the smaller x, so we get 2x minus 28 will equal 20. Add 28. Oops, sorry. So 2x, sorry, this thing popped up. Here we go. 2x will equal 48. I didn't mean to make that line either. Sorry, I'm holding my son while holding the iPad and doing this. So I'm trying over here. Divide by 2, and x equals 24. So a lot of people typed this in the answer, and they kept getting it wrong, and they couldn't figure out why. It's because you didn't actually answer the question. It wants you to know what the measure of RS is. Well, currently, the measure of arc RS is 6 times x minus 28. Well, we need to plug in our x, which is 24. So 6 times 24, which is 144, go ahead and subtract 28. So we get 116 degrees. So again, a lot of people got this wrong because they just circled this as the answer when you have to plug in your x. Moving on to 10.4, these are called inscribed circles, or inscribed angles. Inscribed angles sit on the circle, whereas central angles sit on the center of the circle. So inscribed angles are half of its arc, and the arc is 2 times the angle, whereas a central angle and its arc are congruent. So here, it says find the measure of angle N. Well, this is angle N. In order to find the measure of its angle, you need to know the measure of its intercepted arc. So in order to do that, we need to look at this arc is a semicircle because N and L sit on the diameter, which means this arc is 180 total. Whoop. And you already have 160 of it. So that means this piece is 20, and I know the angle is half of its arc. So half of 20 is 10. So the measure of angle N is 10 degrees. This next one, find the measure of arc VU. So in order to know that arc, you need to know this arc, and you're given the angle. The angle is half the arc is going to be double the angle. So it's going to be 60. We know that this sits on the semicircle, because T and U are the diameter. So all the way from T to U is 180. So 180 minus 60 would make 120 degrees. The next two, find the measure of angle G. Remember that angle G corresponds with arc DF. So if we found arc DF, we could half it to find the angle. So in order to know that, if you look, we have all of the pieces except for one in a circle, and we know that all of the arcs add up to 360 degrees. So we could subtract what we already have, which is 70 plus 120, which is 190. So the arc is 170. So that means the measure of angle G will be half of 170, which is 85 degrees. I think I already did this one, but we can change it up. Let's find, just to give us some more review, let's find TUV. Arc TUV. So from T all the way to U. Shh, Zoe, I'm filming. Sorry. So we know all the way around the circle, again, is 360. Oop. Zoe. Zoe. So all of the arc of the circle is being found except for this piece. So if we found this piece, we could subtract it from 360. Well, we found this, I think, on another one. It is double the angle, so it is 60 degrees. So subtract, that means the measure of TUV is 300 degrees. 10.7 was about writing the equation of a circle. So that looked like x minus something squared plus y minus something squared, and it equals the radius squared. So what you do with this is you plug in the center here. So you need to know the center of the circle, which is the origin, 0, 0. So I think what made people get this one wrong, I don't know, is they didn't simplify these two. X minus 0 is x, and it's still squared. Y minus 0 is still y. Then the radius is the distance from the center to the edge, which 1, 2. So it'd be 2 squared, which is 4. So this part was matching on the quiz. Tell whether the following lines or segments are a tangent, secant, chord, radius, or diameter. Tangents and secants are lines that go infinitely in both directions. Tangent touches the circle once, secant is twice, whereas the others are, they start and they stop, so they're segments. So the first says OB, and it is a segment, so it's one of these three options. It goes from O to B. It goes from the center of the circle to the edge of the circle, so we call that a radius. Next one is BC, and if you see there's lines above, so guess how many options there are for BC? Just 2 options, because it is a line that goes infinitely in both directions. It only touches the circle once at B, so that makes it a tangent. Tangent. Next one is OA. Man, that's easy. OA would also be a radius. AB is a line. It has arrows above. So let's see how many times it touches the circle. Oh, touches the circle in 2 places. So that makes it a secant. And then last, we're going to do AB. It is a segment. So it's from edge to edge, which makes it a chord, but it's a special type of chord because it goes through the center, which makes it a diameter. Yeah, a chord would have been, a diameter is a type of chord, but I wanted the most specific. A chord would look like this, or it could look like this, something like that. The next section that had common mistakes was tell how many common tangents the circles have. A tangent touches the circle once, so you're looking for a line that would touch the circle once, each of them once. So it said internal. This one would have 0 internal tangents. I'll put it over here. Reason being, you need space between the circles to have an internal tangent. So the lines I just drew, they would be internal. Or if you had them this direction, there would be internal tangents. But there are no internal tangents because there's, where'd it go? Because there is no space between the circles. Here's why. I mean, obviously you would say, oh, there's space here. But what would happen? A tangent only touches the circle once. If you made a line here, it touches this small circle once, but it touches this circle twice, which would mean it's not tangent, if that makes sense. And then external would, this one is 0 and 0. So 0 internal. Yeah, right there, bud. 0 external. Because again, external would be on the outer portions of the circle. So like this example, internal. Internal, they're always going to like cross like this. Doop, doop. Pretend that these touch beautifully. So there would be 2 internal, and then there would be, ooh, that's ugly, 2 external. 2. I think we have 2 more. Sorry if this is out of order. I'm not looking at my computer to see what you see, but this question, it says in the diagram the circles are congruent. So that means, because they're congruent, that means they have the same radius. Alright? So, find the measure of DE. So a lot of you look at this and you're like, there's no numbers. You're right, there isn't. There's just a property that you would need to remember. So if you look, SW is the radius, right? Radius goes from center to the edge. Well, wouldn't ST also be the radius? And the definition of a circle is that it has the same radius all the way around. Well, you know, figuratively, that's the So that means that this side is congruent to this side, and since this side was already congruent to this side, that means I have an equilateral triangle. All of the sides are equal, which means all of the angles are equal. So when all of the angles are equal, there's 180 degrees in a triangle, split it 3 even ways. That makes each angle 60. So if you're finding this arc, sorry if it's not highlighted well, if you're finding, try it again, this arc, it corresponds with this angle. Since it's a central angle, they're going to be congruent. So TW is 60, which means DE is also 60. Then last, this one had check boxes. You had to check in the diagram. Circle B is congruent to circle C. Identify all the red arcs that are congruent. So in order for arcs to be congruent, they have to have congruent radii, and they have to have congruent measures. So obviously B and C, the circles are congruent, so by definition their radius, their radii are congruent. So that means this one's marked 98, so that means LK is congruent for sure with MN. Most people got those right off the bat. Some even got this one, HK, or HJ, sorry. So the angle I've highlighted and the angle across, they're vertical. Oh, it also just marks them congruent. Silly me. Congruent, congruent. So that means this angle is 98, which means this arc is also 98. So that would be HJ. But then we started looking at the other circle. So when things are congruent, something to think about, to be congruent, they have to be the same length and measure. So length, think that. So I don't know what the radius is here, right? I don't know. But I know in order for this arc, even though it has the same measure of 98 degrees, I don't know the radius, right? So I would hope that you can see that this circle is indeed smaller than this circle. So they don't have the same radius. So they are not, that arc, even though it is 98 degrees, it is not the same length as the other ones that we mentioned before. So it is not congruent. Nothing about this circle is congruent with the other ones. So I believe that is where we stop. Email me if you need any other examples, have any other questions. Good luck.